Have you ever really looked at the bugs in your backyard? And I mean, really looked. Have you ever wondered if they're just random accidents of nature or maybe, just maybe, tiny high-tech machines? Today, we're shrinking down to explore the incredible world of beetles and flies. And I think you'll be surprised to find they're less like simple pests and more like miniature marvels of engineering. So let's keep this one big question in the back of our minds as we go through this. Are these creatures the result of countless random accidents over time, or are we actually looking at masterpieces of engineering? Keep that question right there as we dive in.
All right, first up, the armored tanks of the insect world, beetles. We're diving deep into the order Coleoptera to see exactly what makes these little walking fortresses so unbelievably tough and successful.
You know, the name itself is a huge clue. Coleoptera actually comes from the Greek for sheathed wings. And that one feature, that sheath, is the absolute key to understanding this massive group of insects. We're talking over 350,000 different species here. So here's the basic beetle blueprint. The star of the show are the elytra. Those are the hard outer wings that act like a protective shield. Now, they aren't for flying. Instead, they cover a second, much more delicate pair of wings that are folded up super safely underneath. When the beetle decides it's time to take off, that armor lifts up, the flight wings unfold, and bam, it's ready for action. You combine that with powerful chewing jaws, and you've got one seriously tough bug. But that blueprint, that's just the starting point. Let's look at how that basic design gets customized into some absolutely incredible specializations. Think of these next few beetles as little case studies, each one equipped with a unique set of tools for a very specific job. Okay, let's start with one we all know and love, the ladybug. But it's so much more than just a cute beetle. The ladybug is a high-performance predator, and it seems perfectly designed for a special mission right in your own garden. And get this. A single ladybug can eat up to 500 aphids in one day. That's not just a big appetite, that's like a precision-engineered pest control system in action. Next up, the firefly. This little beetle comes equipped with one of nature's absolute coolest technologies, bioluminescence. We're talking a living light. And it's not just a pretty glow either. It's a complex communication system, a living flashlight used to send coded messages and find a mate in the dark. And here's the really wild part. This ability isn't just for the adults. Fireflies can glow at every single stage of their life, even as tiny eggs and larvae. It's like the programming for this living light is built in from the very, very beginning. Okay, now for a beetle that has to live in two different worlds at the exact same time. The whirligig beetle skates on the surface of ponds. Now, that creates a huge problem, right? How do you scan the sky for predators and look for food down in the water simultaneously? Well, the solution is just brilliant. This beetle is equipped with 4 compound eyes. 2 are positioned to see above the water, and the other 2 see below it. It's a perfectly split visual system designed to master both worlds at once. Sticking with the water theme, how does an air-breathing beetle go hunting underwater? Well, the predaceous diving beetle solves this with a piece of equipment that is so clever it works just like a scuba tank. It's an amazing process. The beetle comes to the surface, hangs upside down, and traps a bubble of air under its elytra. You know, that armored shell we talked about. It then takes that bubble down with it. So that protective armor now doubles as an air tank. The beetle then breathes from this bubble through special openings called spiracles, which lets it stay submerged to hunt. Okay, so from the armored fortress, we're going to pivot to a totally different design philosophy, the agile aviator. Let's explore the world of true flies, the order Diptera, where everything seems to be built for pure speed and precision in the air. And just like with the beetles, the name tells the whole story. Diptera literally means 2 wings. Instead of 4 wings like a beetle, flies have just 1 pair. It's a streamlined design that makes them some of the most incredible acrobats of the air. So the fly's blueprint is all about aerial efficiency. That single pair of wings gives them unbelievable agility. And you could forget chewing jaws. Their mouth parts are specialized tools. They're either like a tiny hypodermic needle for piercing and sucking, or they work like a little sponge for mopping up liquids. Just take the mosquito, for example. The difference between the male and the female is incredible, because they seem to be equipped for totally different missions. The female needs blood for her eggs, so she has a complex mouth part with 6 microscopic razor-sharp needles designed to pierce skin. But the male, he just feeds on nectar, so he doesn't have that specialized equipment at all. It's like they were each given a different toolkit for a very different job. And then there's the common housefly. We see it as a pest, sure, but it's perfectly engineered for its function. It thrives in waste, and its feet are covered with these sticky pads that are absolutely perfect for picking up and transporting microbes from one place to another. And they are absolute masters of multiplication. I mean, just look at this number. Try to even wrap your head around it. If every single one of their descendants survived, a single pair of flies could lead to 190 quintillion offspring in just 5 months. That number is it's almost impossible to imagine. And it points to an unbelievably efficient reproductive design. So let's bring it all together. We have these two very different groups of insects, and each one has a design that seems perfectly engineered for its specific purpose. Let's do a final side-by-side look. The key takeaway here is that we're looking at two totally different design philosophies. For beetles, the main idea is armor and durability, with those hard elytra for protection. But for flies, it's all about agility and speed, with that streamlined two-wing design. Even their tools are completely different. Powerful chewing jaws versus delicate surgical-like probes. Each one is a master of its own domain. You know, we've really only scratched the surface today, but the pattern is so clear. From a beetle's built-in scuba tank to a mosquito's surgical needle, the insect world is just packed with complex, specialized equipment that serves a very distinct purpose. And that brings us right back to our big question from the beginning. We've seen armor plating, living flashlights, four-eyed navigation systems, and built-in scuba gear. So when every single part has such a clear and complex purpose, what does that suggest about a designer? That's something to think about. Thanks for watching.